you ever really watched a pot of water start to boil? The bubbles tend to come near the heat source first, and their paths are sort of wiggly. Maybe you even notice the motion at the surface is turbulent and spreads out from certain points. If you've seen this movement, you've seen convection. Convection is the heat transfer due to bulk movement of fluids. Near the heat source, water is warmed, rises to the top, and then cools at the surface and sinks to the bottom. Convection is driven by differences in density due to temperature changes. Warmer, less dense material is rising, and cooler, more dense material is sinking under the influence of gravity. Convection doesn't just happen in pots of water, either. In our atmosphere, there are large convection cells called Hadley cells. Because of the angle of Earth's tilt and position with the sun, the equator receives a much more consistent heat from the sun than the polar regions. The warmed air rises from the equator regions, moves toward the poles, cools, then sinks back to the Earth's surface. Warm air also rises at the 30-degree latitudes, which cool at the poles. Convection also occurs in the oceans. Again, large amounts of warming occurs at the equator. Then the water moves toward the poles, which are much cooler. As water cools, they're continuously moved until they're back at the equator to be warmed again. Scientists also hypothesize that the mantle of Earth itself is convecting. The interior of Earth is very hot, and magma moves toward Earth's surface, cools, and then sinks toward the center. This mantle convection is the proposed driving force for plate tectonics. Where magma rises, we should see spreading rifts or hotspots. Where magma falls, it can pull the continents with it, creating subduction zones, mountains, and even volcanoes. Thanks for watching this episode of Teacher's Pet. Don't forget to like and subscribe and follow me on Twitter @SciencePet.